Hey everybody, this is Larry. This is day 12 of the Leetcode April 30 days challenge. Um, let's take a look at today's problem. Last stone weight. Last stone weight. We have a collection of stones. Each stone has a positive integer weight. Each turn, we choose the two heaviest stones and smash them together. Suppose the stone have weights x and y, where x is less than or equal to y. The result of the smash is if x is equal to y, then both stones are destroyed. If x is not y, then the stone of weight x is totally destroyed, and the stone of weight y is now y minus x. At the end, there is at most one stone left. Return the weight of the stone, or 0 if there's no stone left. Okay. So I think we can just keep on doing it. So there are a couple of ways to do it. You could where n is just 30, right? So then we can, because every turn we want to smash the two heaviest stones, so let's do it. So I think there's just simulation where the simulation is just with 30 stones. You could probably get computationally very expensive if you like, but for my sake, I'm going to use heap for this algorithm, where we just take, repeatedly take the two largest element, and that's great. Get on it. Heap is probably available as in your favorite language, so definitely look up your libraries if you're not familiar with it. But with heap, then you can just get the top thing every time. And in this case, we want the max heap because we just want the two heaviest stone every time, right? Okay. So in Python, it is a min heap. But yeah, okay. So let's just copy stuff away, which is there's also another way to write that to be cleaner. I don't know if this is cleaner actually, but yeah. And I like to write it out to be explicit, though. I guess that gets bigger than 1 because you keep on smashing it. Oh. I guess I have to heapify. Like heap, something like that, I think. In I'm just trying to think whether this is this does this in place. I believe so. So I don't have to like otherwise I would have to do something like this, but I think that's not actually necessary. Then okay, so then now for every time we just pop off. I don't know, I actually messed up this one a little bit because we actually want the max heap, but as we said in Python, is the heap queue library. We get the min heap. So a little bit of a hack, and what I'm going to do is to transfer. There are a couple of ways to transfer this. You can maybe change the comparison function, but I'm going for stone in stones. I'm going to do a common hack, which is to change the stone, which works with integers anyway, from a max heap to, or from a min heap to a max heap by multiplying by -1, then heapify it, and then now we can get the two heaviest stones, which is the two biggest elements. Let's get the biggest one first, which is and then remember there's one p or two p's. I think that makes sense. So and now we get the second one, and then now we just push back the y minus x, right? Yeah, I guess in this case we would get 0, but we could push back 0. I think that's fine. Then there'll be one more case. Maybe that's okay. Then we want the negative of this to kind of remember what we said, but let's actually check that out. Okay, and then now we just have to return whatever's left. Let's check this. The negative version of this. So why did I do this? Otherwise, just return 0. They only gave us one result, so let's try like something. Let's try some edge cases, one, and then also just two answers are smashed together, or two stones are equal, and then you get no stones left. Okay, that looks okay. Do I have any more edge cases? Look at the constraints. There should be anything. I was going to consider maybe 0 or something like that, or maybe even negative numbers, to be honest. But it seems like it's okay, so that's okay. Let's submit. Cool. Yeah. So what is the complexity of this 15-line solution? And should be similar in your language of choice. Maybe a little bit less hacky. Maybe I think I would clean it up because I'm using like a lot of negative to get the max heap instead of the min heap. But in most languages, I think this convention should be the max heap, so you don't need to do this hack. So your code is probably already clean. But again, this is, I mean, I don't think in terms of me trying to do a code review right now, I don't think this code will be that much cleaner in general. I might try to figure out how to pass in a comparison function so that you would return the opposite of the less operator for the comparison. But mostly ignoring that, it's pretty much clean. Yeah, so that's my code review for this problem. How would I think about this as an interviewer? I mean, this is pretty basic, so I think this definitely is something that I would recommend studying. Heap is very common on interviews and the real world. It allows us the complexity of n log n, which I guess I didn't talk about, but yeah. So heapify is going to be linear, and then we do this. We will do this all of n times because every time you go through the loop, I mean, you go through this loop n times because every time you go through the loop, you remove one element, and each of these loops cause all of log n, making this n log n algorithm. Yeah, but as I said, heaps are very fundamental. I think you could probably do something more naive if you like, since n is equals to 30, which just feels pretty low. Like you can keep sorting every time if you like, and that'll be n squared log n. But it would still pass the Leetcode constraints, but probably on an interview that would not fly. As an interviewee, this is, as I can say, this is pretty straightforward, both as a competitive programmer and an interview candidate. So definitely, I would like, you should know what a heap is. Similar problems, and yeah, I think there are definitely possibly other ways to do it, but heap is probably the easiest one to keep the min as you keep inserting as a priority queue. Let's see what the hint is. Simulate the process. We can do it with heap. Yeah, I mean, they say I listed both these possibilities, and you could maybe, I mean, if you like, you could like do some sort of insertion sort every time, and then get that n square algorithm or something like that, or depending on how you do the insertion, maybe even n cube. But yeah, overall, pretty straightforward problem. Hopefully tomorrow will be more interesting. And thanks for watching. Hit the like button, hit the subscribe button, hit all the buttons. Uh, Thank you.